It travels. It is not even halfway across.
14. 100,000 years is the entire history of modern humanity. When the light started its journey across the galaxy, our ancestors were just beginning to migrate out of Africa. They were using stone tools. They huddled around fires in caves, looking up at the same stars we see today, unaware of the light that was already rushing toward them. As that light crossed the spiral arms, we learned to farm. We built pyramids. We invented. Welcome to the Sleepy Academy. You have arrived at a sanctuary designed for rest, a quiet corner of the world where the noise of the day simply fades away. Here, we believe that true relaxation comes from the gentle rhythm of words and the soothing cadence of a narrative told without haste. Before we drift into tonight's journey, if you find comfort in this space we have created, please consider gently pressing the like button. It helps other weary souls find their way to us. And if you wish to return here for future nights of deep rest, we invite you to subscribe to our channel. Now, take a moment to make yourself comfortable. Adjust your pillows, let your shoulders drop, and allow your breathing to slow down. Close your eyes, clear your mind, and let us begin. The architecture of distance. In the vast, silent stretches of the night sky, where the darkness seems to go on forever, there exists a measurement that defies our ordinary understanding of the world. It is a concept born from necessity, arising when the tools we use to measure our daily lives simply cease to function. We call this measurement the light year. On the surface, the phrase sounds familiar. It is composed of two words that we use every day. We know what light is. We see it filter through the curtains in the morning. We watch it cast shadows across the floor in the afternoon. We rely on it to navigate our rooms when the sun goes down. And we know what a year is. We feel it pass in the changing of the seasons, in the slow growth of trees, in the turning of calendars. These are comfortable words. They are human words. But when they are combined into the single unit of astronomy, they create something that sits strangely in the mind. A light year sounds like a measure of time. It has the word year right there at the end, suggesting a duration, a period of waiting, a long stretch of hours and days. But it is not a measure of time. It is a measure of distance. It is a phrase that carries more physical space than the human mind was ever designed to hold. It is the distance that light, moving at its unwavering cosmic speed, can travel in a single year of uninterrupted motion. To understand what this really means, and to understand why we need such a strange unit, we must first look at how we understand distance itself. We must look at the ground beneath our feet and the way we move through the world. Distance for us has always been physical. It is tactile. It is something we feel in our bodies. For thousands of years, to know a distance was to know the effort required to cross it. A short distance was a few steps across a room. It was the time it took to walk from the hearth to the door. A medium distance was a walk to a neighbor's house, or perhaps a journey to the nearest river. These distances were measured in strides, in the rhythm of breath, in the tiredness of legs. If a place was far away, it meant that you had to pack food. It meant that you had to wait for the weather to clear. Distance was an obstacle. It was something that resisted us. It was tied inextricably to the speed at which a human being could walk. Even as we began to build tools to help us move, our sense of distance remained anchored to the earth. We built ships to cross oceans, and we measured the journey in days and weeks. We watched the coastline fade and waited for a new coastline to appear. The ocean was vast, certainly, but it was still a surface. It was still something that could be traversed. Later, we built trains that cut through the landscape, blurring the trees and fields, compressing the time it took to travel between cities. Then came cars, and eventually airplanes, which shrank continents into a matter of hours. But through all of this, distance remained something we could conquer. It was a problem to be solved with speed. If a place was far away, we simply moved faster. We built better engines. We paved straighter roads. We defined distance by how long it took us to get there. But space is different. Space does not cooperate with our instinct to conquer it. When we look up at the night sky, we are looking at a realm where our traditional understanding of movement begins to fail. Beyond the atmosphere of our planet, the familiar units of kilometers and miles begin to stretch thin. They are designed for roads and maps, for borders and bridges. They are not designed for the void. As we move away from the Earth, past the orbit of the Moon and out towards the planets, the numbers we use to describe distance start to become unmanageable. They grow so large that they lose their meaning. We can write them down. We can say that a planet is millions of kilometers away. We can say that a star is trillions of kilometers away. The mathematics are precise. The numbers are correct. But the human mind cannot truly hold them. When we hear a number like 1 trillion, we might nod politely. We might acknowledge that it is very big, but we do not feel it. It becomes abstract. It becomes just a string of zeros on a page, conveying precision but not understanding. The mind blurs. The imagination retreats.
This mind-blowing animal-performing human activity is taking over TikTok accounts with millions of views and generating thousands in revenue. Let me show you how to do that in seconds using AI. Head over to Ideogram and type this prompt. A playful orange tabby cat is sitting outside in a cornfield, having fun with fresh corn on an old wooden table. It swipes at the loose corn kernels spread across the table. Behind the cat, there are tall green corn plants and a farmhouse, creating a warm and peaceful countryside feel. The soft, natural light makes the scene look happy and relaxing. Then, set the aspect ratio, choose a model, and hit generate. Now take this generated image to this website, add a little prompt, and hit create. Comment AI, and I will send you the prompt and website links.
Racing across the galaxy. We are drifting. We are allowing the concept of distance to unfold at its own pace, layer by layer, until we can sense the quiet vastness that lies between.
This mind-blowing animal-performing human activity is taking over TikTok accounts with millions of views and generating thousands in revenue. Let me show you how to do that in seconds using AI. Head over to Ideogram and type this prompt. A playful orange tabby cat is sitting outside in a cornfield, having fun with fresh corn on an old wooden table. It swipes at the loose corn.
Universe to survive. They needed to know how far a predator was. They needed to know if a shelter was close enough to reach before nightfall. They needed to know if a fruit tree was within a manageable radius for gathering. Our brains evolved to handle distances that mattered to our survival. We became experts at judging depth within a few hundred meters. We learned to lead hawks with
This
tail.
isn't just any chat,
learned to
it's
read the
ClickUp
terrain.
chat. Sure,
But
you can tag your
evolution gave
team,
us no
ask
tools for
questions, and
emptiness.
even drop an emoji.
It gave us no
But the
reason to prepare for a void stretching millions of times farther than the horizon. When we try to visualize the distance to a star, we are using a mind that was built to visualize the distance to a watering hole. It is a mismatch of machinery. It is like trying to measure the depth of the ocean using a wooden ruler. It is not that the ruler is wrong, it is simply that the ocean is operating on a completely different scale. This is why space feels so strange to us. It is not just big, it is fundamentally disconnected from effort. On Earth, if you walk long enough, you will eventually get somewhere. You will see the landscape change. You will pass landmarks. You will feel the progress in your muscles. In space, you can travel for 1,000,000 kilometers and see nothing change at all. The stars will look exactly the same. The darkness will look exactly the same. There is no wind to feel against your skin. There is no road passing beneath your feet. There is only the sensation of floating, of drifting through a silence that has no edges. This absence of landmarks strips distance of its texture. It becomes smooth. It becomes silent.
it becomes difficult to sense.
3. This is the environment where the light year lives. It is a unit of measurement for a place where walking is impossible and where driving would take eternity. To understand it, we have to look at the fastest thing we know. We have to look at light itself. Light is so familiar to us that it almost disappears into the background of our lives. It fills our rooms when we wake up. It reflects off the surfaces of our tables and chairs. It delivers the colors of the world to our eyes. It seems instantaneous. When you flip a switch, the lamp turns on immediately. When you open your eyes, the world is just there, waiting for you. It does not feel like light is traveling. It feels like light is simply present. But light is not static. It is a traveler. It is a stream of energy moving through space at a specific, finite speed. It is not infinite. It does not happen everywhere at once. It flows. It ripples outward from its source like a wave moving across a pond, only much, much faster. Physicists discovered long ago that light travels at a speed that is woven into the fabric of the universe itself. It moves at approximately 300,000 kilometers every single second. Even that number is hard to visualize. 300,000 kilometers in 1 second. To put that into perspective, in the time it takes for your heart to beat once, light could circle the entire Earth 7 times. It is a speed that defies our instincts. It is so fast that for all practical purposes on Earth, it might as well be instant. But space is so vast that even this incredible speed begins to look slow. And this is the key to understanding the light year. It is the realization that the universe is so large that even light needs time to cross it. When we leave the surface of the Earth, the delays begin to appear. The moon, our closest companion in the night sky, is close enough that we can see the craters on its surface with a pair of binoculars. It looks like it is just right there, hanging just above the trees. But the moon is roughly 384,000 kilometers away. It is a distance that light, moving at its unimaginable speed, takes just over 1 second to cross. If you were standing on the moon and you flashed a light toward Earth, a person watching from their garden would not see it instantly. They would have to wait. 1 second. It is a tiny pause, a heartbeat, a blink, but it is there. It is the first hint that distance is transforming into time. As we move further out, the pause grows longer. The sun, the source of all our warmth and daylight, sits about 150 million kilometers away. That distance is enormous, but in the language of light, it is measured in minutes. It takes sunlight about 8 minutes and 20 seconds to travel from the surface of the sun to the surface of the Earth. 4. This means that the light warming your skin on a summer afternoon is not fresh. It is 8 minutes old. It has been traveling through the cold vacuum of space while you were making breakfast, or while you were reading a book, or while you were simply sitting still. It began its journey, and it crossed the void, and it arrived 8 minutes later. If the sun were to suddenly vanish, we would not know it for 8 minutes. We would still see it shining in the sky. We would still feel its gravity holding us in orbit. We would be living in the past, blissfully unaware that the source of our light was gone, until the last stream of photons finally arrived and the sky went dark. This delay is the foundation of the light year. It teaches us that looking out into space is really looking back in time. It teaches us that distance is not just a gap between two objects, it is a lag in information. It is a waiting period. And as we move beyond the Sun, past the orbits of Mars and Jupiter and Saturn, the waiting period stretches from minutes.
But they're actually
into
AI
hours.
generated. I tried making a few myself, like a cat working out at the gym, a cat flying through the sky like Superman, and even a cat working as a professional software developer. Eating vegetables, reading a newspaper, but without changing this example prompt format. Then, click Generate, and that's it. ChatGPT will instantly give you creative and hilarious prompts for your viral cat videos. Create 10 funny prompts featuring only an orange tabby cat wearing glasses in a cornfield doing some crazy things. For example, cooking, cutting vegetables, reading a newspaper, but without changing this example prompt format. Then, click Generate, and that's it. ChatGPT will instantly give you creative and hilarious prompts for your viral cat videos. Once our prompt
around the equator in millimeters. You could do it mathematically. You could write down the number. But it would be a number so long, so cluttered with zeros, that it would convey nothing but confusion. And so, astronomers use the light year. They ask, if light travels at 300,000 kilometers per second, and it never stops, and it never slows down, how far would it get if you let it run for an entire year? The answer is a distance of about 9.5 trillion kilometers. That is 1 light year. It is a distance that is impossible to visualize. Our brains simply shut down when we try to picture a trillion of anything. But we don't need to picture the kilometers. That is the beauty of the unit. We only need to picture the time. We only need to imagine a beam of light moving silently, steadily through the dark for 1 full year. Think of the patience in that movement. Think of a year in your own life. Think of all the things that happen in 12 months, the changing of seasons from winter to spring, to summer to autumn and back to winter again. Birthdays, holidays, projects started and finished, relationships changing, books read, meals eaten, nights of sleep. A year is a long time for a human being. It is a significant portion of our experience. Now imagine that for that entire time, through every minute of every day of that year, a beam of light has been rushing through space. It has not stopped to rest. It has not slowed down for traffic. It has moved at the absolute cosmic speed limit, covering 300,000 kilometers with every tick of the clock. And at the end of that year, the distance it has covered is 1 light year. That is the measuring stick we use for the universe. It is a ruler made of time and speed. And the most humbling part of this concept is that the nearest star to us, a faint red star called Proxima Centauri, is not 1 light year away. It is more than 4 light years away. The light we see from that star tonight left its surface 4 years ago. It has been traveling through the emptiness while we lived 4 years of our lives. It is a message that has been in transit since the recent past, carrying the image of a star across a gap so wide that physical travel is almost inconceivable. This is why the light year is such a quiet, relaxing concept. It forces us to accept that we cannot rush. The universe is built on scales that demand patience. It is built on distances that make our fastest jets and rockets look like they are standing still. If we were to get into a car and drive at highway speeds, roughly 100 kilometers per hour, and we tried to drive 1 light year, we would have to keep driving for more than 10 million years. The human species has not even existed for 10 million years. We would have to drive through the rise and fall of civilizations, through the shifting of continents, through the evolving of the planet, just to cover the distance that light covers in 1 single year. This comparison helps us let go of the idea of conquering space. It helps us settle into the idea of witnessing it. We are not travelers on these scales. We are observers. We are watchers. We are sitting on a small, quiet rock, looking out into a vast, dark ocean and catching the waves of light that wash up on our shores. And each wave tells us how far it has traveled by how long it took to arrive. The light year tells us that the universe is deep. It tells us that the universe is old. It tells us that everything we see is a memory. In the chapters to come, we will drift further out. We will move beyond the nearest stars, out to the edges of the galaxy, and then into the profound emptiness between the galaxies themselves. We will see how this single unit, the light year, stretches to accommodate the mind-bending size of the cosmos. We will explore what it means to look millions of years into the past. We will find comfort in the fact that we are small and that the universe is large, and that there is a slow, steady rhythm to the way information moves through the dark. But for now, we simply acknowledge the first step. We acknowledge that distance is not just space. Distance is time, and the light year is the bridge that connects them.
6. The training ground of seconds and minutes. Before we can truly understand the vast, silent ocean of the light year, we must first learn to swim in the shallower waters of our own home. We must understand the local neighborhood. In astronomy, local is a relative term. To a human being, local means the street outside the window or the town down the road. To the universe, local means the solar system. It means the family of planets, moons, asteroids, and comets that circle our sun. Even here, in this relatively small pocket of space, the distances are already growing beyond what our minds can comfortably grasp in kilometers. We are used to seeing the solar system in diagrams in school textbooks. In those pictures, the planets are lined up neatly in a row. They look like colorful marbles sitting on a table, close enough to touch one another. Mercury, Venus, Earth, Mars, they seem crowded. But those diagrams are lies of necessity. They have to squeeze everything onto a single page, so they remove the one thing that defines space more than anything else, the emptiness. If we were to draw the solar system to scale and we made the Earth the size of a peppercorn, the Sun would be a ball of gas roughly the size of a bowling ball, and it would be 26 meters away. Jupiter would be a chestnut more than 100 meters away. Pluto would be a grain of sand located a full kilometer away. And in between these tiny specks of matter, there would be nothing but empty, silent air. This is why we need light to measure even our own backyard. We need a ruler that can span the silence. And so we begin to measure not in years, but in seconds and minutes. This is the training ground. This is where we learn that looking at the sky is an act of waiting. Let us start with the closest world to our own, the moon. It hangs in the night sky, large and luminous, covered in the gray scars of ancient impacts. It feels like a companion. It controls our tides. It lights our paths. It watches over us while we sleep. It feels near. And in cosmic terms, it is. But even this nearest neighbor is separated from us by a chasm of emptiness that defies easy travel. The Apollo astronauts, strapped into the most powerful rockets ever built by human hands, took 3 days to cross that gap. 3 days of drifting through the blackness. 3 days of silence. But light is faster. Light does not drift, it rushes. When we look at the moon, we are seeing light that left the lunar surface just over 1 second ago, 1.3 seconds to be precise. It is a distance of about 384,000 kilometers. In the time it takes to take a single deep breath, light can make that journey. It is a light second. This is a manageable unit. We can feel a second. We can understand it. It is the duration of a heartbeat. It is the time it takes to blink. When the astronauts on the moon spoke to Mission Control in Houston, there was a pause. They would say something, and their voice, carried by radio waves which travel at the speed of light, would take just over a second to reach Earth. Mission Control would hear it and answer immediately, but their answer would take another second to travel back to the moon. The result was a conversation filled with small, unavoidable gaps, a rhythm of waiting. Silence, voice, silence, answer. That silence was not a technical failure. It was the physical manifestation of distance. It was the universe gently reminding us that even close neighbors are not in the same room. Now let us turn our attention inward toward the center of our system, the sun. It dominates our sky, burning with a ferocity that sustains all life on our planet. It looks like it is right there. We feel its heat on our faces the moment we step outside. But that heat is an illusion of immediacy. The sun is 150 million kilometers away. It is a distance so vast that a commercial jet flying without stopping would take nearly 20 years to reach it.
7. Light, however, makes the journey in 8 minutes and 20 seconds. This is a light minute. It is a scale that fits into a human routine. 8 minutes is the time it takes to boil a kettle and make a cup of tea. It is the time it takes to listen to 2 slow songs. It is a short walk around the block. In that brief span of mundane time, light has crossed the cold, dark void between the star and the planet. It has raced past the orbit of Mercury, past the thick clouds of Venus, and arrived at our atmosphere. There is a strange and beautiful thought that comes with this delay. When you watch the sunset, when you see that great orange sphere touching the horizon, dipping below the edge of the world, you are watching something that has already happened. The sun has already set. Physically, geometrically, it is already below the horizon. But the light carrying the image of the sun is still streaming toward you, 8 minutes behind reality. You are watching a ghost. You are watching a memory of the sun. The universe is playing a trick on your eyes, preserving the moment for just a little longer than it actually existed. As we turn our backs on the sun and look outward into the deeper dark of the outer solar system, the light minutes begin to stack up. We move past Mars, the red planet. Depending on where Earth and Mars are in their orbits around the sun, the distance between them changes. Sometimes they are close, sometimes they are on opposite sides of the star. The time it takes for light to travel to Mars varies from about 3 minutes to nearly 22 minutes. Think of the rovers that crawl across the surface of Mars right now, robot explorers dusting the red soil. When engineers on Earth send a command to tell a rover to turn left or to take a picture, they press a button, but nothing happens. The signal leaves Earth, flashing out into the void at the speed of light. It travels for 10, maybe 15 minutes. It crosses millions of kilometers of nothingness. Finally, it arrives at Mars. The rover receives the command and turns left. It sends a signal back saying, "I have turned." That signal takes another 15 minutes to return to Earth. For the engineers sitting in their chairs, a full half hour has passed since they pressed the button. They have to wait. They have to trust. They have to accept that they are not driving the rover in real time. They are guiding it through a delay. They are interacting with the past. This is the lesson of the solar system. The further you go, the deeper into the past you must reach.
Beyond Mars, the distances expand dramatically. We reach the realm of the gas giants. Jupiter, the king of planets, a swirling ball of storms and clouds so large that it could swallow 1,000 Earths. It sits far out in the cold. Light from the sun takes roughly 43 minutes to reach Jupiter. 43 minutes, that is a lunch break. That is a television episode. It is a significant chunk of an hour. If someone were floating in the clouds of Jupiter, looking back at Earth with a telescope, they would not see us as we are now. They would see us as we were 43 minutes ago. They would see us doing things we have already finished doing. Then comes Saturn with its magnificent icy rings. Saturn is nearly twice as far from the Sun as Jupiter. The light takes about an hour and 20 minutes to get there. An hour and 20 minutes of silence. An hour and 20 minutes of moving through the dark with no landmarks, no air, no sound. Just the steady, unwavering progress of photons flying away from the Sun. And then the ice giants, Uranus and Neptune. These worlds are so distant that they are barely visible to the naked eye, faint points of light lost among the stars. Sunlight takes nearly 2 hours and 40 minutes to reach Uranus. It takes over 4 hours to reach Neptune. 4 hours. Imagine standing in the sunlight at noon. That same light, that same pulse of energy will not touch the clouds of Neptune until 4 o'clock in the afternoon. It is a journey that spans half a workday. By the time we reach Pluto and the scattered icy rocks of the Kuiper Belt, we are 5.5 hours away from the Sun at light speed. The Sun from Pluto is no longer a blinding disk. It is just a very, very bright star in a black sky. It provides little heat. The daylight on Pluto is weak and watery, like the light of dusk on Earth. The delay is profound. A message sent from Earth to a probe near Pluto takes 5.5 hours to arrive. A round trip takes 11 hours. You could send a message in the morning, go about your entire day, eat dinner, and get ready for bed before the reply returned. This is the scale of our own neighborhood. It is measured in hours. It is vast, yes. To a human being, it is inconceivably large. But to the universe, it is nothing. It is a speck. It is a grain of dust. Because even at Pluto, even at the edge of the darkness where the Sun's influence begins to fade, we have not yet reached a single light year. We haven't even come close. A light year is not 5 hours. It is not a day. It is not a week. It is a year. 8,760 hours. To reach 1 light year, you would have to travel the distance from the Sun to Pluto roughly 1,600 times. You would have to stack 1,600 solar systems end to end just to span the distance that light travels in 1 year. And remember, the nearest star is over 4 light years away. This is where the brain begins to stumble. We feel like we have traveled a long way just to get to Pluto. We have crossed billions of kilometers. We have passed giant planets and asteroid belts. We have spent hours moving at the speed of light, and yet we have barely left the driveway. We are still standing on the doormat of the cosmos. The distance between the edge of our solar system and the very next star is a void so deep, so wide, and so empty that it makes the distance between the planets look like a crowded room. In that void, there are no planets to mark the way. There are no rest stops. There is only the drift. There is only the long, silent glide through the interstellar medium, the thin soup of particles and dust that fills the space between stars. This is where the light year truly begins to matter.
It is where light minutes and light hours become too small to be useful. We need a bigger ruler. We need a ruler that can handle the silence of the deep ocean. Consider the Voyager probes, Voyager 1 and Voyager 2, launched by humanity in the 1970s. They are the fastest objects ever built by human hands. They have been flying for over 45 years. They have flown past Jupiter, past Saturn, past Uranus and Neptune. They have left the planets behind. They are moving at roughly 60,000 kilometers per hour, a speed that is terrifyingly fast by Earth standards, and yet in light years, they have traveled nowhere. They have traveled less than 1 day of light time. They have been flying for nearly half a century, and they have not even covered the distance light covers in 24 hours. If Voyager 1 were heading directly toward the nearest star, which it isn't, but if it were, it would take over 70,000 years to get there. 70,000 years. That is the difference between chemical rockets and the speed of light. That is the difference between human movement and cosmic scale. It is a reminder that we are slow and the universe is big. But there is a comfort in this slowness. There is a peace in knowing that we cannot rush. We cannot force the universe to be smaller than it is. We can only watch it. We can only listen to it. The solar system, with its light minutes and light hours, teaches us patience. It prepares us for the longer waiting that is to come. It teaches us that separation is natural, that delay is built into the physics of reality. When we look at Saturn, we are waiting for an hour. When we look at Neptune, we are waiting for 4. We are practicing. We are letting our minds stretch, slowly, gently, like a muscle warming up. We are getting ready to look beyond the edge, into the true dark, where the light takes not hours, but years and centuries and millennia to reach us. So let us rest here for a moment. Let us drift in the space between the planets. Let us float in the 4-hour gap between the Sun and Neptune. It is quiet here. It is calm. There is no wind. There is no noise. There is only the faint, distant warmth of the star and the endless velvet black of the vacuum. We have learned the scale of minutes. We have learned the scale of hours. We are ready now to turn our eyes outward to the places where the calendar becomes the clock and the light year becomes the only way to speak of the distance home.
10. The ocean between the islands. We have left the planets behind. We have drifted past the icy giants, Uranus and Neptune, and we have floated silently through the scattered debris of the Kuiper Belt, where Pluto and its frozen cousins wander in the dark. Now we are crossing a boundary. It is not a solid wall, nor a line drawn on a map. It is a fading. It is the place where the wind from the sun, the stream of charged particles that blows outward from our star, finally loses its strength. It pushes against the thin, sparse gas of the galaxy, and it falters. This is the edge of the heliosphere. This is the true border of our home. Beyond this point, we are in interstellar space, the space between stars. If the solar system was a house, we have just stepped off the front porch and into the night. And the first thing we notice, the overwhelming sensation that defines this new realm, is emptiness. When we were near Earth, space seemed busy. There were satellites, debris, the moon, the other planets visible as bright wandering lights. Even in the outer solar system, there was a sense of structure. We knew the sun was there, holding everything in place with its invisible gravitational tether. But here, in the deep void, that structure feels distant. The sun is just a star now. It is the brightest star in the sky, yes, but it no longer dominates. It has become a point of light, shrinking with every moment of travel, merging into the backdrop of the Milky Way. We are entering the ocean between the islands. The distances here are so vast that they defy the analogies we used before. We spoke of light minutes and light hours. Those units are now too small. They are like trying to measure the depth of the Pacific Ocean with a teaspoon. We must switch to the light year, and even then the numbers are humbling. The nearest star system to our own is the Alpha Centauri system. It is not a single star, but a family of 3. There is Alpha Centauri A, a bright yellow star much like our Sun. There is Alpha Centauri B, a slightly smaller orange star. And there is Proxima Centauri, a small, faint red dwarf that circles the other 2 from a great distance. Proxima is the closest of them all. It is our nearest cosmic neighbor, and it sits at a distance of roughly 4.2 light-years. 4.2 light-years. Let us hold that number in our minds. It sounds small. 4 is a small number. You can count to 4 on one hand. But remember what a light-year is. It is 9.5 trillion kilometers. It is a year of continuous, breathless speed. To say that Proxima is 4 light-years away is to say that light, the fastest messenger in the universe, must travel for 4 years, 2 months, and a few weeks without stopping, just to cross the gap. Imagine a beam of light leaving the surface of Proxima Centauri. It flashes into existence, born from the swirling plasma of the star. It flies outward, escaping the star's gravity, and enters the void. For the first year of its journey, it encounters nothing. It flies through absolute darkness. There are no planets to pass, no asteroids, no dust clouds large enough to matter. It is just the photon and the silence. A year passes. On Earth, the seasons have turned. A birthday has come and gone. The light is still traveling. It has covered 9.5 trillion kilometers, and it is still in the middle of nowhere. It is not even halfway there.
A second year passes. The light rushes on. It is utterly alone. The silence of interstellar space is profound. There is no air to carry sound. There is no friction to slow it down. It is a perfect, frictionless glide. The light is as fresh and as bright as the moment it was born, preserved by the emptiness. A third year passes, then a fourth. Finally, after more than 50 months of travel, the light begins to approach our solar system. It crosses the heliosphere. It races past Neptune and Uranus. It flashes past Saturn and Jupiter. It crosses the orbit of Mars. And finally, 4 years and 2 months after it left its home, it strikes the lens of a telescope on Earth. It hits the retina of an astronomer's eye. And in that moment, the astronomer says, "I see the star." But they do not see the star as it is. They see the star as it was 4 years ago. They are looking at a ghost. If Proxima Centauri were to flare up today, if it were to release a massive burst of energy, we would not know about it for 4 years. The news is traveling, but it is stuck in the slow lane of the universe. We are cut off from the present. We are surrounded by history. This distance of 4 light-years is the closest anything gets to us. That is the stark reality of our position in the galaxy. We are isolated. The gaps between stars are not like the gaps between houses on a street. They are like the gaps between ships scattered across a lonely ocean. If the sun were a grapefruit in New York City, the nearest star would be another grapefruit in Los Angeles. And in between them, across the entire continent, there would be nothing but a few drifting molecules of gas. This isolation is why interstellar travel is so incredibly difficult. It is not just an engineering problem, it is a problem of scale. To bridge the gap to Proxima Centauri using our current technology would take tens of thousands of years.
It would be a journey of generations. A ship launched today would drift through the silence for millennia. Civilizations would rise and fall on Earth. Languages would change. History would be written and rewritten. And all the while, the ship would be floating in the dark, barely moving relative to the scale of the distance it has to cross. But there is a beauty in this isolation. It means that each star is its own private island. Each star is a sanctuary. The events of one solar system do not easily spill over into another. We are safe from the storms of our neighbors. Gravity, which holds planets in their orbits, weakens over these vast distances. The Sun holds us tight, but it has no grip on Alpha Centauri, and Alpha Centauri has no grip on us. We drift past each other, separated by the cushion of light years, engaged in a slow, graceful dance around the center of the galaxy. Let us look deeper into this void. What is actually out there in the space between the Sun and Proxima Centauri? It is not truly empty. It is filled with the interstellar medium. This is a thin, tenuous soup of hydrogen and helium gas, mixed with tiny traces of dust. But when we say thin, we mean thin beyond comprehension. The air you are breathing right now contains billions and billions of molecules in every cubic centimeter. In the interstellar medium, you might find one atom in a cubic centimeter. One single, lonely atom floating by itself.
It is a vacuum better than anything we can create in our best laboratories on Earth. It is so empty that light can travel through it for thousands of years without ever hitting anything. It is so empty that it offers no resistance. It is the perfect environment for light to carry its message. This is why we can see the stars at all. If space were filled with air like our atmosphere, the light from distant stars would be scattered and absorbed long before it reached us. The sky would be a fog. We would see nothing but a gray haze. But because space is empty, the light remains pure. It cuts through the dark like a laser, preserving the image of its source across the abyss. As we drift through this region, we can imagine the view. Without the atmosphere of Earth to scatter the sunlight and turn the sky blue, the sky is always black. It is a deep, velvety black, studded with diamonds. The stars do not twinkle here. Twinkling is caused by the air on Earth moving and shifting. Here, in the void, the stars are steady, unblinking points of piercing light. They look hard and cold, and they are everywhere. Above, below, to the left, to the right, we are suspended in a sphere of stars. And yet, despite their numbers, they feel far away. They do not illuminate the darkness around us. If we were floating in deep interstellar space, far from any star, it would be pitch black. Your hand in front of your face would be invisible. The nearest star would be just a bright dot, offering no warmth. The cold would be absolute. The temperature sits just a few degrees above absolute zero. It is a deep, permeating cold that has existed for billions of years. This is the environment that light conquers. It travels through the cold, through the dark, through the emptiness, carrying the story of the universe. It connects the islands. It is the only connection we have. We cannot touch the stars. We cannot hear them. We can only see them. We are bound to them by these thin threads of light that stretch across the light years. When we look at the Alpha Centauri system, we are looking at a potential mirror of our own home. Astronomers have found planets orbiting Proxima Centauri, worlds that sit in the habitable zone where water might exist. It is tantalizing to think that just 4 light years away, just next door in cosmic terms, there might be a landscape of rocks and canyons, perhaps even an ocean. But that distance is a wall. We can see the light reflecting from it, but we cannot reach it. We can only wonder. The light year teaches us humility. It teaches us that we are small and that our reach is limited. But it also teaches us that we are part of a larger fabric. The light from Alpha Centauri falls on your eyes when you look up at the southern sky. The photons that traveled for 4 years end their journey on your retina. You are physically touching the universe. You are catching the rain of light that has fallen across the galaxy. As we move further out, beyond the nearest stars, the numbers begin to grow again. 4 light years becomes 10. 10 becomes 100. We start to see stars not as individuals, but as clusters. We see the Pleiades, the Seven Sisters, a group of young, hot blue stars huddled together in the dark. They are 400 light years away. The light we see from them left during the time of Galileo, when the telescope was first being turned toward the sky. We are watching them as they were centuries ago.
13. We see the Orion Nebula, a glowing nursery of star formation, where new suns are being born from clouds of dust and gas. It is 1,300 light years away. The light we see tonight left the nebula before the fall of Rome. It has been traveling while empires rose and crumbled, while maps were drawn and redrawn, while humanity spread across the globe. All that history passed in the blink of an eye for the light beam as it rushed toward us. Every time we look at a different star, we are looking at a different depth of time. The sky is not a flat canvas. It is a deep, three-dimensional history book. The farther we look, the further back we read. We are time travelers standing still. We are archaeologists of the sky, digging into the past with our eyes. And the light year is our shovel. It is the tool that allows us to make sense of the layers. It tells us that this star is from the last decade, and that star is from the last millennium. It organizes the chaos of the night into a structured timeline. It turns the static dome of the heavens into a flowing river of time. So let us drift a little longer here, in the quiet space between the Sun and Alpha Centauri. Let us appreciate the 4 years of emptiness that separate us. It is a buffer zone, a quiet place, a place where nothing happens and where everything is possible. The light passes through, silent and steady, weaving the universe together, 1 year at a time. The City of Silence. We have learned to accept the distance to our neighbors. We have accepted that 4 years of light travel separates us from the nearest star. But in the grand design of the cosmos, 4 light years is merely the width of a single room. We are now ready to step out of the house entirely and look at the city in which we live. This city is the Milky Way galaxy. When we look up on a very dark night, far away from the lights of human cities, we see a faint glowing band stretching across the sky. It looks like spilled milk, a river of pale light flowing through the darkness. The ancients saw it as a pathway for the gods or a celestial river. But what we are actually seeing is the collective light of billions of stars, so distant and so numerous that they blur together into a single haze. We are looking edge-on into the disk of our own galaxy. The Milky Way is a spiral galaxy. If you could fly millions of light years above it and look down, it would look like a slowly spinning pinwheel. It has a bright, dense center, glowing with a golden light. From this center, great arms of dust and gas and blue stars curve outward, spiraling into the blackness of intergalactic space. It is a thing of immense beauty, but it is also a thing of immense size. To cross the Milky Way, from one edge of the disk to the other, light must travel for 100,000 years. 100,000 light years. Let that number settle. We struggled with 4 years. We tried to imagine the patience required for a beam of light to travel for 4 years. Now we must imagine that same beam traveling for 1,000 centuries. It leaves a star on the outer rim of the galaxy. It flies through the emptiness. It passes nebula after nebula, star cluster after star cluster. It watches civilizations rise and fall on 1,000,000 different worlds. It watches species evolve and go extinct. It watches mountains wear down to sand. And still it travels. It is not even halfway across.
14. 100,000 years is the entire history of modern humanity. When the light started its journey across the galaxy, our ancestors were just beginning to migrate out of Africa. They were using stone tools. They huddled around fires in caves, looking up at the same stars we see today, unaware of the light that was already rushing toward them. As that light crossed the spiral arms, we learned to farm. We built pyramids. We invented writing. We fought wars. We built cities of glass and steel. We flew to the moon. And only now, after all of that human struggle and triumph, does the light finally reach the other side. This is the scale of the Milky Way. It is a city of stars, yes, but it is a city built on the foundation of silence. It contains perhaps 200 billion stars, 200 billion suns. Some are smaller and redder than ours, some are massive blue giants that burn with a furious heat. But despite this staggering population, the galaxy is mostly empty space. If you were to randomly appear somewhere inside the Milky Way, the chances of you being near a star are vanishingly small. You would likely find yourself in the deep, cold dark between the systems. You would look around and see stars as distant points of light, just as we do from Earth. The galaxy is not a crowded room. It is a sparse archipelago. It is a collection of lonely islands separated by vast oceans of night. We live in one of the suburbs of this city. Our solar system is located in the Orion Arm, a minor spiral arm located about halfway between the center of the galaxy and the outer edge. We are about 26,000 light-years from the downtown core. This is a quiet neighborhood. The stars here are spread out comfortably. We are not buffeted by the intense radiation of the galactic center. We are not threatened by the chaotic activity of the dense star clusters. We are drifting in the calm waters of the galactic disk. But everything is moving. The galaxy is not a static painting, it is rotating. The entire spiral disk is spinning, turning slowly like a great wheel in the dark. But the speed of this rotation is measured in geological time. Our sun and all the planets with it are orbiting the center of the galaxy. We are moving at a tremendous speed, hundreds of thousands of kilometers per hour. But the distance we have to cover is so vast that the motion seems imperceptible. It takes the sun roughly 230 million years to complete one single orbit around the galaxy. This is called a galactic year. The last time the Earth was in this position in its orbit, dinosaurs were just beginning to appear on the planet. The continents were shaped differently. The Atlantic Ocean was just a narrow rift. The world was unrecognizable. Since then, we have traveled all the way around the wheel, a journey of nearly 160,000 light-years in circumference, and we have arrived back here. In the lifespan of our sun, which is about 4.5 billion years old, we have only circled the galaxy about 20 times. We are young travelers. The galaxy is ancient. It turns with a slow, heavy majesty that mocks our hurried sense of time. If we look toward the center of the galaxy, toward the constellation of Sagittarius, we are looking into the heart of the city. But we cannot see it clearly with our eyes. The center is hidden behind thick curtains of interstellar dust. These dust clouds hang in the spiral arms like dark fog, blocking the visible light from the dense cluster of stars in the core. If we could see through that dust, the night sky would look very different. The Milky Way would not be a faint band, it would be a blazing streak of fire, bright enough to cast shadows on the ground. The center of the galaxy is packed with old red stars, swarming around a supermassive black hole that anchors the entire structure.
But the dust protects us. It keeps the sky dark. It keeps the mystery. The light from the center takes 26,000 years to reach us. It fights its way through the dust, scattering and reddening until only the faintest glow remains. When we look at that glow, we are seeing the galaxy as it was during the last ice age. We are seeing the light that left a core when vast glaciers covered the northern hemisphere of Earth. And what of the other side? What of the stars on the far rim of the galaxy, 70,000 light years away? We will likely never see them. They are too faint, too distant, too obscured by the bulk of the galaxy itself. We share this city with billions of neighbors we will never meet. We are separated not by walls, but by time, by the sheer insurmountable patience